Let us solve a problem, that is transportation problem. So the question goes like this: use Vogel's approximation method to find the IBFS for the following TP. This is the best way of solving a TP to find the IBFS, because it gives you an optimal solution, very close value to the optimal solution. As usual, we can see that we have number of rows and columns named. We have something which is available here, and we have which is demanded. What is available and what is the demand. As we all know that before even starting the TP, the first condition is to check whether the sigma AI and sigma Bj are matching. So let us add the numbers here. We get 21, 9, 30. In this case, again we get 30. So here we can see that the total of all the available and the demand is actually matching. So that means to say that sigma AI is equal to sigma Bj. Hence, it is a balanced TP. So that means the solution exists. Okay, first we are supposed to find the column difference and the row difference. So in the particular row, search for the smallest number and a number next to it. So 8 is the smallest and the next number is 9, and difference between both is 1. Don't worry about the sign again. The least in the next row is 7 and the next number to that is 10. So difference becomes 3. We have 9 and 11. Difference is 2. We have 10 and 12. The difference is again 2. Similarly, find the column difference. In the first column, we can see that 10 is the least and the next number to 10 is 11, and the difference between them is 1 here. Then we have 7 as the least and the 9 is the next number. Difference becomes again 2. 8 and 10, the difference becomes 2. Now among all the elements in the L shape, among all the elements, all the differences, choose the highest. So 3 is highest and put a star mark to it, meaning whichever is highest, that row gets the allocation. So in this particular row, where do we make the allocation? The allocation has to be made to the smallest number that we have. So the allocation starts here. Now we can see here we have 10 and 7. The smallest among 10 and 7 is 7. That means to say this whole row gets cancelled. You can extend it till the end. Okay. So if 7 is already given, this becomes 3 more remaining. Again, start with the row difference and column difference. We can see in the first row, the least is 8 and the next number is 9. So difference becomes again 1. The second row is already cancelled, nothing to write. 9 and 11, the difference becomes 2. Similarly, we have 10 and 12, the difference again becomes 2. So come back to the column difference. We can see that we have 10 and 11, so the difference is again 1. Now we can see that 9 and the next number is again 9, so the difference among them is 0. We have 8 and 10, so the difference becomes 2. Now the question is that since you have so many 2's with you, it is your choice which 2 that you would like to choose, because all of them have the same weightage. I just select this as the point. I just put a star mark here. That means to say the allocation has to be made to this particular column. Where do we do? Wherever we have the least number. We can see that 8 is the smallest, so we make the allocation at this place. 9 and 8, so the smallest is 8. I give 8. That means 8 actually gets cancelled. This whole row gets cancelled, and we can see here that only 1 is remaining. Now come back. We have only 2 rows. Again find the row difference here also. 9 and 11, the difference is 2. Again 12 and 10, the difference is 2. Come back to column. We have 11 and 12. Still the difference is 1. 9 and 14, we can see that the difference becomes now 5. 13 and 10, the difference is 3. Now among all these L-shaped numbers, find the highest. We can see that 5 is the highest number and put a star mark for 5. That means we have to make an allocation in this particular column, and we can find that 9 is the smallest. So give the allocation for this particular cell. We know we have only 3 here, but the demand is around 9. So give the least. So 3. That means to say once we give 3, this whole column gets cancelled and we can see that 6 more is remaining. Now again we are left with the next row, that is third row. 11 and 13, the difference is again 2. 12 and 10, the difference is again 2. Here we can see that 11 and 12, the difference is again 1. The column is already lost. 13 and 10, the difference is 3. Now we can see that among all these, 3 is the highest. Put a star mark to this particular 3. That means we have to make the allocation in this column. Again I repeat, wherever we have the least element we are supposed to make the allocation. So I just choose this cell. We can see that the remaining number is only 1 and demand is 6. So the least being 1, I am going to block this and this whole column again gets cancelled. And we can see that after giving 1, the remaining element is 5. Now come back, we can see that we have 2 rows here, and from this row I have only 11 as the remaining number, and from this row I have only 12 as the remaining number. Come back here, we have 11 and 12 for the column difference, and the difference being 1. So among all this we can see this 12 is the highest. Put a star mark, meaning in this particular row you have to make the allocation, and we can clearly see that there is only one element left here. So I make the allocation. It is 11 and 5. So give 5 because that is the least, and the whole row gets cancelled. And when you give 5 here, remaining is 6. And the last element, we can see that the only element available is 11, and this 11 itself gets the highest, and we know only one cell is remaining, so give the allocation here. And at last we can see that the demand is also 6 and the available, both available and demand are matching. That means give the allocation as 6. So the whole row and the whole column gets cancelled. Now we can see that the allocation is complete. So I would repeat, every row find the least and the next number to the least, find the row difference. Similarly, find the column difference, and among this row and column difference, whichever is highest, mark it with a star, and you are supposed to make the allocation there. And where do you make the allocation? Wherever you have the least element. So this is the least element and you give the allocation there. Continue in this way to calculate your allocations. Once we do this, we are supposed to find the TTC. So the total transportation cost for this problem is, as usual, we are supposed to consider only the cell with the allocation. So it starts with 8 into 8 plus we have 7 into 7, yes, 7 into 7 plus 6 into 11 and plus 3 into 9 we have 5 into 12 and 1 into 10. I can just check 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5, 6 allocations, and when we multiply and add together, the total that we get is 276. Therefore, the total transportation cost for this problem is 276. And previously also I have mentioned, once we finish with the IBFS, to find an optimal solution, the basic requirement is to find whether m plus n minus 1 and the number of allocations are matching. That means just to check whether it is a degeneracy problem or a non-degenerate problem. So in this case, let us calculate m plus n minus 1. It should be equal to number of allocations. This is the condition. Now m being the row, we have 1, 2, 3, 4 rows, plus we have 3 columns minus 1, which is equal to 6. And let us check 1, 2, 3, 4, 5, 6. Yes, it is equal to your number of allocations. Therefore, it is non-degenerate. Once we have this condition, we can go ahead to find the optimal solution, either using a Modi method or the stepping stone method. Thank you.